All right, recording is started. All right, this is day one of 5.04. We're going to convert points. Not too bad. So I think this is a 3-day lesson. Let me just double check. Unit 5. So, nope, this is only 2 days. So we have today and tomorrow for 5.04, and then we'll start 5.05 on Wednesday.
And that ends on Friday.
Why is it a Friday?
So we have the quiz tomorrow for this one, and then 5.05 quiz on Friday. That's the way the schedule says it, at least. So you have 2 quizzes this week, one tomorrow, one on Friday.
Correct. Yes, because 5.05 starting on Wednesday is a 3-day lesson. You have day 1, day 2, day 3. So yeah, Friday you will have the quiz for 5.05. Tuesday for 5.04. All right, so make sure you copy this page down or snip it. So this is going from polar to rectangular. And rectangular, it's just the classic x comma y, the Cartesian coordinate plane. Whereas polar, we learned last week, Thursday and Friday, that even though you have 2 values, your first one is r, for you can think of it as radius, and second being theta, which is the angle in radians. All right, so don't forget that sine is just y over r, and cosine is x over r. We learned that last unit, I believe. Maybe it was unit 3, I forget. All right, so then we can reorder those equations to solve for y and x, and that's why y is equal to r times sine theta, and x is equal to r cosine theta. This page shouldn't be new. I think my dog wants to get down. Oh, I think she wants to go to the chair. Yep, she's good. All right, everyone got this page written down? Because you'll need these 2 equations. Okay. What's wrong? Hold on, my dog wants help. She's a big crybaby. She wanted help she wanted me to lift the covers for her to go underneath, because her brother was hogging it. All right, sorry about that. She is a princess. That's what I call her, princess. Yeah. All right, so number 1, we are going to convert all these pairs of polar coordinates into rectangular. So up top, I actually have the conversion here. So number 1, r is 4, theta is pi over 4. So go ahead and write this setup. Go ahead and write that down. All right, so we should have 4 cosine of your theta, and then 4 sine theta. Nothing special in this setup. All right, so when you get your values, you need to make sure you look at what, well, I was going to say you need to make sure you know what quadrant you're in, but it may not matter going from polar to rectangular, but we still should check. So pi over 4, what quadrant is that? Quadrant 1. So when you convert from polar to rectangular, rectangular to polar, if we start with quadrant 1, your converted coordinate should also be in quadrant 1. That's important to check, kind of the beginning, middle, and end. And you'll see that I think it matters more when going rectangular to polar, but we'll see. We will see. All right, so we're in. So the radius is 4, angle is pi over 4, so we're in quadrant 1. So that kind of tells us if we're in quadrant 1, x and y should both be positive, and that's really what you're getting out of that. X and y is both positive. All right. So looking at your unit circle in quadrant 1, because that's where we're going to be. Cosine of pi over 4. So what is the cosine of pi over 4 using your unit circle? Go ahead and write in chat. So Antonio says rad 2 over 2. Anybody else agree with that? Rad 2 over 2. We got some more people agree. Emily yells rad 2 over 2. All right. So rad 2 over 2. Remember, cosine is the x value. So the x value at the angle pi over 4 is rad 2 over 2. All right, what is this? What's the sine value, the y value of pi over 4? Oh, same thing. Yep. All right, so go ahead and multiply that. You got 4 times rad 2 over 2, and then again 4 times rad 2 over 2. What do we get? 2 rad 2. We sure do. So there's your answer. Any questions on converting from polar to rectangular? It is simple enough. I agree. So let's do. You think 2 minutes for number 2 is going to be enough? It might be just enough. We'll see. All right, everyone, do number 2. Get you 2 minutes. Ready, go. I think number 2, you can probably just kind of think about this problem and actually not show any work and still get the right answer. And maybe after you work this out, mathematically, you can kind of probably think about it and say, hey, I could have thought of this answer versus doing the math. Let's do this. When you finish, go ahead and give me a green check when you are done. Don't click the X yet because we still have time. But when you finish, go ahead and give me the green check. All right, time is up. Go ahead and if you're still working, give me the X. I know at least you're here. Give me an idea who's actually present. So even though you're in chat, you made it, doesn't mean you're actually here. George, you still here? Haley, you still here? Julia? There you are. Hmm. Wish I can throw people in the fun house. Right. We got two people that are not here. Sad day. All right, go ahead, guys, and chat. People who are done. What is the final answer? -1 comma 0. Very good. Very good. And what I said earlier for this problem, if you think about it, well, you have a radius of 1, and then the angle is pi. So remember, pi is a half a rotation, right? So that means if you rotate counterclockwise, a half a rotation, you are on the x-axis with a radius of 1. So you can visualize that. Oh, that's -1 comma 0. It's, if you just think about what's going on, you can just kind of pull it out of your head, I guess. But mathematically, let's take a look. We just set it up in cosine of pi and sine of pi. So we get -1 and 0. And we just, well, do the math. And that's how you get the answer. All right, everyone do number 3. Let's give you another 2 minutes. Ready to go. Please tell you this is all the lesson is. Yeah. Well, we have to go the other direction, but yeah, it's more or less this is all it is. It's not really going to get much harder. Capri Sun. Doesn't Capri Sun have a lot of sugar in it? You should care. It's not good brain food. All right. So time is up. Let me take a poll again. So green check if you are done with this problem. Number 3, X if you are still working. And if you don't answer, I am kicking you out of this lesson because you're not here. So green check if you are done. Give me an X if you are still working. So at least I know you're here. Sad day. People who aren't here. Uh, people who this is, I'm doing 2 strikes, you're out. Oh, George, welcome back. So, all right. If you're here, give me a X. You kick people out. Oh, found it. Found it. Here we go. All right, and chat, go ahead and give me what your final answer is. A lot of 02s. So 02 is quadrant. Well, it's not even a quadrant. There's a name for that. I forget what it is, but you are on the y-axis. Forgot the name of it. Did anybody recall what that name is? If I saw it, I'd recognize it, I think. So when you were on an axis, what is that called? It's a
plane?
definition. No, it's not. It is the y-intercept. There's actually a name for it. We learned it in either unit 3 or 4. I forget. Probably because it's not that important. All right. So let's see what the final answer is. Yep, 02. And I'm just going to show the work. This is what you should have got. All right. And then, everyone, I'll give you 2 minutes for number 4. Ready, go. And just to save time, if you are already done with number 4, just go ahead and give me a green check. Don't click the X yet. So, but when you do finish number 4, give me the green check. All right, so time is up for that one. If you're still working, give me the X, so at least I know you're here. So again, if you're done, green check. If you are still working and you are here, give me the X. All right, looks like two strike rule. Remember, if you're here, give me the X. If you're done, give me the green check. All right, looks like someone else is leaving us. Sad day. Sad.
I'm sorry, but for some of us, it didn't show up.
Didn't show up.
I think if you already clicked on it, that's why it's like not showing up for you guys. Unless you made a new one.
Danica, was that you talking?
That was Araceli.
Oh, Araceli. I think you already responded. No, you didn't, Araceli. But you are here, so I won't boot you. Yeah, she didn't respond. Okay. All right, I'll do baseball rules. 3 strikes and you're out. All right. And chat, go ahead and write the coordinate, please. We got, oops, scrolling 3 rad, 3 all over 2, comma, negative 3 over 2. So again, 3 rad 3 over 2, comma, negative 3 over 2. So that would put us in quadrant what? What quadrant is that?
That'd be 4.
Quadrant 4. Yep. So your answers in quadrant 4 is the original problem in quadrant 4 as well.
Yes, sir.
All right, and we are golden, I think. Let's take a look. Yep, 3 rad 3 over 2, comma, negative 3 over 2. Nice job. And here's the work setup. All you got to do is use that unit circle. This should be pretty quick. So there's no rationalization needed. So it's pretty quick. You're not typing stuff in. You're setting it up. You're looking at your unit circle. You're pulling whether it's X or Y value, throwing them in, and then you just simplify it. It's a pretty quick process. Who be scribbling? Oop, they erased it. I couldn't see. All right. Okay, volunteers. So we're gonna graph these now. We're gonna graph it. We're gonna graph the polar points we found along with the original points. And I color coded them so it's less confusing. All the polar points are blue and all the rectangular are yellow. So we have problems 1, 2, 3, and 4. So I need volunteers. I need volunteer for polar number 1. So we'll do polar points first. Let's graph those. Graph polar point number 1. Volunteer. I see quite a bit of you are actually tabbed out. So again, I can see who's actually tabbed in and watching this presentation versus tabbed out. Jacob immediately tabbed back in. Smart man. So volunteer, guys, come on. There's a bunch of people here, and nobody wants. You're just plotting the points. This is going to be on your quiz and test, so it's not like you're doing it for nothing. Okay, so let me scroll back up. All right. Antonio, number 1 polar. Caitlin, number 2 polar. Sarah, number 3 polar. And Chloe, number 4 polar. All right, now for the rectangular points. I'll take volunteers for those. Emily, number 1 rectangular. All right, another volunteer. George, number 2 rectangular. All right, Naya, number 3 rectangular. Okay, Antonio, number 4 rectangular.
I can estimate these right. You're not gonna mark me wrong if I get these things wrong because
Right, it's just it's an estimate. You can't graph radicals
Okay, cool.
exactly. It's an estimate.
Is it sad I checked your answers here before I marked it?
A little bit. Number one, I think. Emily, do you have number one? My point is whack, but it's
Good number 2.
who had number one rectangular? I forgot who I assigned that to. George, maybe? I don't remember.
I can do it if needed.
Yeah, go ahead just to get it done real quick. I forgot who I had number one. Julia, you got to
do
hop
it.
on the mic before Antonio does. He's a mic hog.
Thank you. So it's gonna be somewhere here, roughly, kind of, sort of, maybe. It is somewhere here.
It's definitely not where it's at.
Wait, did I do something? Oh, wait, hold on. Ah, okay, I see you. I was testing you.
Sure you were.
It was. It's somewhere roughly there.
Okay, I'll take that. All right. So the whole point of graphing the rectangular and polar form is to show that if you were to transpose, is that the right word? Transpose one on top of the other. I think it's the right word, right? Someone correct me if I'm wrong. Someone who knows words. Superimpose. Superimpose is the word I'm thinking of, not transpose. Superimpose. Thank you. So if you're superimpose one on top of the other, they would be in the exact same spot. That's the whole point of doing this. So whether you're graphing polar or rectangular of that numbers 1 through 4, the location is still going to be exactly the same place. Pretty neat, right?
The more you know.
The more you know. Neat. Okay, so that's a way. So when you convert one to the other, you could just plot both points in Desmos. I think Desmos does polar. There's a way to switch the graph to polar format. If you do that,
can switch the graph to polar, but I haven't found how to graph the actual polar points. Like I can switch it to the circle, but I don't know how to actually graph the points because when I type it in, it just plots the rectangular.
If we have time, I'll take a quick look at it and see if I can figure it out real quick. I'm pretty sure I've done it.
Okay, cool. Thank you.
Yeah, I'll take a look at it. All right. So before we go on, converting from polar to rectangular, questions?
No, but I did notice something as well.
What'd you notice?
So each of these things here, they also match up over here. You see ones, I'll touch, ones, twos.
Not seeing it.
Okay. See how the circle here is 1, right? The
Okay.
first circle. All of them touch right here at 1 as well as the circle. Then second. Seeing it now, or you're still lost?
No, that makes sense because, well, remember, this is the radius, right? This circle. So we have radius of 1, 2, 3, 4. It's the same thing. If you were to plot your points, this could be considered radius of 1, 2, 3, 4 as well. It's the same thing. So I see what you're getting at. This right here, this is a radius of 4. If you were to do the Pythagorean theorem, starting at the origin from here to here, and you created a triangle, and you did the Pythagorean theorem, you would discover from the origin to that point is a distance of 4. And that's actually a good observation you made. As people were in chat are thinking, well, yeah, Antonio, that's pretty obvious. But it's an important observation that all of you make.
A quick question.
Yeah.
So this is the 4th, correct? This outer one?
I believe so, yes.
So then why does this number 1 fall on 3 on this graph?
Well, because that's the x distance. From here to here is your x value. Then from here to here is your y value. And remember, so you visualize making a triangle, x being a leg, y value being a leg, and then from the point to the origin is your hypotenuse, your radius. A squared plus b squared equals c squared. Now, if you calculated that, you would get your hypotenuse being a length of 4.
All right, I'll trust you on that.
Well, we're going to do it here in a minute. So you can trust me now and then see it in a few minutes. Crazy. Here it is. Wow. Math is great. All right. So snip this page. You're going to need it or write it down. So the conversion. So we're going to go from rectangular to polar now. We're going the other direction. So when you're given x comma y, to find your r value, well, it's the Pythagorean theorem. A squared plus b squared equals c squared. And we just, to solve for r, you just square roots. That's why we get to this bolded formula. So the r value is the square root of x squared plus y squared. That is the Pythagorean theorem right there. To find the angle, we know that tangent is equal to your y value divided by your x value. So to find the angle, we just inverse tan both sides, and that's how you get y. Inverse tan arc sine of y over x. And you would use your unit circle. You could even type this in, and it would probably give you the correct answer. But again, you need to check which quadrant you're in and make sure that angle is also in that same quadrant. So with tangent, if it's not, you're going to have to add a half a rotation. Okay, so let's get number 5. All right, we want to convert the xy coordinates, so -2, 2 rad 3 to polar. And then there's the formula right here. So go ahead and set this up as you see here. You're just basically plugging in x and y into, well, x and y up here. So we're going to go ahead and set that up. Right, so that should look like that for your r value, radical of all that stuff. Always verify that I typed it right. Hopefully I did. And then inverse tan or arctan, I almost said arc sine twice, arctan of your y value divided by your x value.
I agree with you, so you're good.
All right. Everyone's on the same page now? Okay, so then let's everyone go ahead and simplify this. We can probably just type this part in and hit enter and just make sure you have it in simplified radical form. If your calculator does not give you simplified radical form, you're going to have to do it by hand. And everyone in pre-calc has the ability, the knowledge to do that. Right, so looks like radical 4 plus 12 is, well, radical 16, which is 4.
Didn't get that. I don't know if I'm. Oh, okay. I see it. Never mind. I had to stop.
All right, so arctan of negative rad 3. Now, again, I've said this multiple times. Hopefully on your unit circle, you actually have written in at least quadrant 1 what the tangent value is equal to. So looking at arctan of negative rad 3, we know that we're going to be in quadrant 2 because of the original problem, negative 2 comma 2 rad 3. That's quadrant 2. So when we pull out the tangent value, we're going to be in quadrant 2 as well. So that's a given. And hopefully all of you have your tangent values written out for those angles. It's going to make, doing this repetitive work just, well, no more repetitive. You just pull it out from your unit circle. So what is the angle that's in quadrant 2? That's tan, arctan is equal to, or not equal to, arctan of negative rad 3. What is that? 2 pi over 3. So at the angle 2 pi over 3, y divided by x equals negative rad 3. I agree. And there's your answer.
I typed it in the calculator to check it, and I got negative pi over 3.
You sure did. You sure did. Because remember, calculators have a domain restriction built into them. So we learned this in... Right. Okay, so remember. So I'm going to repeat it just for everyone else. It's the domain restriction for tangent is from negative pi over 2 to positive pi over 2. So it's quadrants 4 and quadrant 1 is the domain restriction for tangent. So that's why you don't really want to use your calculator because, well, it uses those restrictions. That's why you want to use your unit circle. Now, one thing you could do is, now, Emily, what was the value it gave you in your calculator?
Negative pi over 3.
So negative pi over 3, where's my reading glasses? Negative pi over 3 puts us at 5 pi over 3. So if you use your unit circle, you can see that because you're rotating clockwise pi over 3, it puts us at the 5 pi over 3 mark. Now, because that's quadrant 4, the original problem, the coordinate is in quadrant 1. Now, because of that fact, you have to rotate from that point 180 degrees, clockwise or counterclockwise, doesn't matter. And if you rotate that half a rotation, it puts you at 2 pi over 3. So you could do it that way. If you want to type it in, you hit enter, and then you confirm your quadrant. We're in the wrong one. We're in quadrant 4 instead of quadrant 2. No, right away, you got to rotate 180 degrees or pi. Same difference, same thing. But using the unit circle, you'll never pick out the wrong value. Forgot where I put my glasses. Couldn't see it. Right. No, Sarah, I did not say rotate 180 from pi over 3. I said rotate 180 from 5 pi over 3. So if it makes no sense to you, everything I just said the last 2 minutes, don't type it in your calculator. Use your unit circle. If you use your unit circle, you don't have to worry about this whole negative rotation stuff because this right here is in quadrant 2. So it means that the angle you pull out should be from quadrant 2. Coordinates in quadrant 2, this angle better be in quadrant 2. So tangent of negative rad 3, remember, it's y divided by x. The combination that gives us negative rad 3 in quadrant 2 is the values from this angle. See? And now you don't have to worry about typing stuff in, getting negative answers, which you have to correct by getting the value by doing clockwise rotations and then realizing you're in the wrong coordinate, and having to do a half a rotation to get to the correct rotation or the angle. So use unit circle. This will be much easier. Good, good, good. Number 5. Okay. All right. So everyone try number 6 is pretty easy, but I'll give you 2 minutes for number 6. I think we might go over time because I think this page is going to take us a bit. Let's try to pick it up a little bit because we only have this slide, and the next slide is just graphing, and that's it. Even though math, I do have a 2-hour block on Mondays and Wednesdays. Doesn't mean I want to teach for 2 hours. Ugh, barf, right? Sitting down for 2 hours and learning this stuff. It's exhausting for you and for me. All right. Let's do this. If you're done with number 6, give me a green check. If you are still working, give me an X. That way I know who's here. If you don't see the polling option like someone did earlier, go ahead and let me know in chat so I don't kick you out right now. Welcome back, Elijah. All right. So a little bit more than half of you are done. How much more time do you need, people that are not done? Another 30 seconds, another minute. What do you want? Oh, 1 minute more? Okay, 1 more minute, 1 minute more. If you're done with number 6, go on to number 7. So 1 more minute. All right, minute is up. All right, so go ahead and chat. Write down what your final answer is. 3 comma 0. 3 comma 0. Well, it's not in quadrant 2, it's between quadrant 2 and quadrant 3. So if you plot that point, you'll see you're going left 3, then up and down 0 for that point. And people who put 3 comma 0, which is actually quite a bit of people, that 3 comma 0 is wrong, because the radius being 3 is correct, but your rotation, so you're saying there's no rotation, which means you are between quadrant 1 and quadrant 4. So remember the whole domain restriction. If you just type that in, it's going to give you the wrong location. Now remember, if you're in the wrong location, all you got to do is rotate 180 degrees, or a rotation of pi, to get to the correct location. And that's why maybe graphing them, just maybe a little sketch of a graph, might help you to make sure that the original, wherever you are, the point, and then the point that you find, in this case, our polar point, is in the same location. If they are, you're done. If they're not, and they're like direct opposites, you didn't do something right. So kind of tricky, right? So it is 3 comma pi, people who got that. So if you got 3 comma pi, nice job. Remember, always check which quadrant or which coordinates between quadrants you're at. How do we know the quadrants? You look at the original problem. So -2 comma 2 rad 3, this is left 2 and then up this, whatever that is. This puts us in quadrant 2. So that's how we know that's where we should be. This right here, if you plot it, you'll also be in quadrant 2. This is on the x-axis. So it's left 3, up and down 0. So you're between quadrants 2 and quadrant 3. This right here, this is a radius of 3, rotation angle of pi. So that puts us in the same spot between quadrants 2 and 3. So yeah, that's why I'm saying you don't want to type these in, because you type this in, you'll get 0, right? And arctan of 0, it gives you 0, but because of the domain restriction that's built into them. That's why you need to use your unit circle, because the arctan of 0 is, well, it's equal to 0. It's also equal to pi. It's also equal to 2 pi. It's also equal to 3 pi. It's also equal to 4 pi and 5 pi and 6 pi and 7 pi and 8 pi, because those are all rotations that will give that a true answer. And we learned about general solutions, right? Remember the general solutions we learned in Unit 4? This kind of applies here. I got fool you once, right, Antonio? Fool you once. All right, number 7. So -1 comma rad 3. Which quadrant are we in? Quadrant 2. So the angle that you find in the conversion should be in which quadrant? Quadrant 2. Yeah, there you go. So in your final answer, if the angle you find is in quadrant 2, you did a good job. If the angle you find is in quadrant 4, shame on you for typing it in. But if you type it in, you get in quadrant 4, but we should be in quadrant 2. Just add pi to it. All right, so we just do the setup. I'm just going to show that. I'll do my timer. We'll do 2 minutes. Two minutes. I made the mistake once. I did actually, Antonio. Of course I've made the mistake. You know, I haven't done this stuff, this trig stuff since probably since the year probably the year 1998, maybe 99. It's been a while. So like, you know, even in college, I didn't do this because this is trig. And if you go to college and you take your placement test, right? And you're going to test into, well, any number of math classes from 082, which is like the super basic math class, all the way up to, you know, wherever. And if you're fortunate enough to somehow test really high and you get into, let's say, Calc 1 for your first year of math in college, well, you skip all those previous courses and you don't have to do trig ever again. And that's what I did. My first math class in college was Calc, so I didn't have to suffer through trig or pre-calc again. Because trig is kind of hard. It really is. So remember, so higher math classes doesn't necessarily mean harder. It's just different material. So like trig can actually be harder than, say, Calc 1. I would probably say maybe it is. Yeah, I would say probably it is. If I was given a choice, take trig or take Calc 1, I would personally probably choose Calc 1. I think it's a little easier. But not for everyone, right? So this stuff, yeah, I've made mistakes because I have to learn it again, you know, after 20 years. And yeah, so. All right, anybody have a final answer for number 7? So it looks like -2 comma 2 pi over 3. Antonio says 2 comma 2 pi over 3. So your R value, wait, I'm sorry. Yeah, your R value will probably always be positive. Probably. So quadrant 1. Nope, that's in quadrant number. So you got to be careful. Let's see. So let me see what people did. 2 comma 2 pi over 3. Now 2 pi over 3. my unit circle. 2 pi over 3. Which quadrant is that? 2 pi over 3, that's in quadrant 2. So yeah, a radius of 2 and the angle is 2 pi over 3. You are in quadrant 2. So that would be, that could be the answer. So let's see what Chloe, see what your answer is. So -2. So Chloe, -2 for the radius and then 2 pi over 3. Because what we learned on Friday, the radius being negative, you go to quadrant 2, which is 2 pi over 3, but because your radius is negative, you have to rotate 180 degrees. So Chloe, your answer is actually in quadrant number 4, not quadrant 2. Right. So yeah, 2 comma 2 pi over 3. So there's the setup. And because the original problem's in quadrant 2, your tangent value that you pull out should also be in quadrant 2. And taking the square root of all that stuff will always be positive. That's what I'm saying, that when you convert from polar to rectangular, your R value will always be positive. You cannot have, based on the conversion, radical of anything cannot be negative. You also don't want to have imaginary numbers, complex numbers. That's something different we're going to learn later on this unit. So 2, and then for the next one, I'm just going to show the work and the answer. Actually, does anybody actually have the answer for number 8 yet? Because I don't want to go over time too much. We're at 11 o'clock, and I don't want to go too far over.
That's meant to say 4 comma 3 pi over 4. My bad. Did you catch that?
I'm sorry, one more time.
That's meant to be 4 comma 3 pi over 4.
Okay. All right. That sounds right. Yep. So, and then here's the setup. That's what we get. Questions on these 4 problems. We're going to graph them just to see it. All right. All right. Problems 5, 6, 7, and 8. Again, I have them colored backwards. So the blue points, those are the rectangular values, and then the yellow points, those are the polar values. It's a good thing I color-coded stuff. All right, volunteer for number one, rectangular. Rectangular. All right, number 1, Antonia, 1 rectangular, go for it. Number 2, rectangular. All right, Emily, number 2, rectangular. How about number 3? All right, Caitlin, number 3, rectangular. Number 4, Julia, number 4, rectangular. All right, number 1, polar. Somebody new that hasn't gone on this page yet. Guys, this is good practice because you're still going to have to be able to do this like on your quiz or your test. And it's okay to be wrong. It's okay to be wrong during class. That way we can, I fool you once, right? But never again. Oh, well, you know what I meant. 5, 6, 7, and 8. All right. So number 5, polar. All right, Antonia, number 5, polar. How about number 6, polar? Looks like Sarah's tabbed out, probably on. Oh, she's back. She did her Insta Twitter post. I ate scrambled eggs today. It was delicious. like my post. Isn't that what people do? I'm not saying it's what
Question.
you do, Sarah. Yep.
Is this 2 pi over 3 right here?
What number?
Oh, no, no. I'm talking about the unit circle. I'm pointing at it. Is this 2 pi
I
over
don't need
3?
you don't have your unit circle in front of you to see if that blurry number matches your unit circle.
I do. The issue is that there's 1, 2, 3. There's 3 plots on mine before it gets to pi, and yours has like 5.
Okay, they're equally spaced, right? So we have 1, 2, 3, 4, 5, 6. So this would be the halfway point, and this
Alright.
would be. I'm answering your question with questions.
No, I'm following you. I know what you're talking
All right,
about.
but it is. I believe it is 2 pi over 3.
Yeah, it is.
It is 2 pi over 3. Yeah.
All right, perfect.
You know, people hate when you ask somebody a question and then they just ask you a question and not answering your question. But I'm asking. So if you message me on Skype or you call me, you ask me a question, I'm going to think about it, and I'm going to ask you a question back to help you realize your question. I'm not doing it to torture you. I'm trying to help you learn.
Text
So don't
opportunity. Can I
get
do this?
so
I don't know.
don't get frustrated. All right. All right. So number 6, Polar. Need another volunteer. Come on, boys and girls. This is our last slide. Let's go. All right, Caitlin, number 6, Polar. Number 7. Danica, are you volunteering? Scaredy cat. You're not sorry. All right. No, yeah, number 7, Polar. Number 8, Polar. Volunteer. People are tabbing out. There's like Sarah's tabbed out. Chloe's bored and tabbed out. Streya's tabbed out. Emily's, jeez. I know, Chloe. I'm just giving you a hard time. Number 8, Polar. Come on. Antonio, number 8, Polar.
Thank you.
No, thank you. Thank you.
Now to decipher this horrible graph real quick. All right, found it. I think. No, I did. Okay, perfect.
Yeah, it's a little blurry.
It's right next to my other one, so that's kind of ironic. All right, there you go.
We just need number 8 over here too, right?
I can go ahead and do that now that we're on it already.
Please do.
All right, so close to here, close to here. So somewhere here, roughly.
Yeah, good enough. You know what? I didn't give you guys any coordinates in quadrant 3 or 4. I should have. Sorry. Maybe on when you go through the modules, learn and practice modules, they'll probably give you a couple in those quadrants. So make sure you do them because they're required. If you are relying on just these live sessions to learn the material and practice the material, it's not enough. You may think it's enough, Not enough, though. It's never enough. Okay, well, that wraps up this lesson. You can see that if you superimpose one on top of the other, they are in the same place. That's the whole idea of converting points from polar to rectangular. You just have a different graphing map, per se, and plotting the points will put them in the exact same spot. So, yeah, there you go. Well, guys, thanks for hanging around. And as always, I hope you learned something. I will see you all tomorrow. Oh, I also wanted to say this before I stop the recording. It's confirmed. So on your NWEA, end of the year test, which is in April, if you show growth on that test, you will be exempt from taking the final in pre-calc. That stress can be just lifted off your shoulders if you show growth on your NWEA test.
I have a question. Do we have to be at like a certain percent? Like, what if
Just-
we show growth by like one question,
There you go.
but like we
that's
get
growth.
a really
right?
bad grade on?
Yeah. You got to just show growth. Yep. Most people in pre-calc scored high anyway. Most of you did. So scoring one point higher, that's okay with me. So we have the grade from your last one. Yes. So a week or two ago, I emailed all the learning coaches your NWEA scores. Just your learning coaches. They have an email that has a PDF in it that you open it, it shows your score versus like the school and the district and whatnot. So bug them to show you that email. All right, guys. See you all tomorrow.